Everybody, we're going to do the now you try problem for how to translate from a verbal description into a numeric, a symbolic, a visual description, and then find the domain and range. We're just going to run through this. The full explanation for how to do these problems is in the previous video. So we are going to read this. Suppose we have a function g that multiplies the input x by 2, then adds 1 to that value, and then multiplies that value by -1/2 to obtain the output of g. All right, so there's 3 steps here. We're first multiplying the input by 2, then adding 1, and then multiplying by -1/2. All right, so we want to give a numeric description to this. So we're going to make our table. We have x and g of x as the output. So we'll try some inputs here. Let's just do like -2, -1, 0, 1, and 5. I'm just choosing some arbitrary numbers. I'm trying to keep them small, but at least a few different numbers here to fill into the table. So let's try these out. If x equals -2, then we're going to multiply that by 2. So -2 times 2. Then we want to add 1 to that next. And then after that, we're going to multiply all of that by -1/2. It's definitely a step more difficult than the last one. So we'll do this in order. -2 times 2 is -4. And we need to add 1 to that still, and then multiply that by -1/2. -4 plus 1 is -3. Multiply that by -1/2 to get a +3/2. Okay, fractions. All right, so if x equals -1 as our next input that we're choosing here, we're going to multiply that by 2. So -1 times 2. And then we're going to take that and add 1 to it. And then we're going to multiply all of that by -1/2. It's just a little bit faster. -1 times 2 is -2. Plus 1 is -1. And we need to multiply that by -1/2. Those multiply together to be a +1/2 with the negatives canceling. Put that in our table. Next, we're going to plug in x equals 0. If our input is 0, we multiply that by 2. Then we need to add 1 and multiply that by -1/2. 0 times 2 is 0, plus 1 is 1, times -1/2 is -1/2. And then we're going to try an input of x equals 1. So we're going to have 1 times 2 plus 1. Take all of that, after we've done that, and multiply it by -1/2. So we'll get 2 plus 1 is 3, times -1/2 is -3/2. Plug that into our table. All right, one more here. We've got an input of 5, say. So we'll take 5 times 2 plus 1, and then take all of that and multiply it by -1/2. And here we'll get 10 plus 1 is 11 times -1/2 equals -11/2. All right, we'll just leave it at that. That's our table. If you use some other numbers, you can just see if maybe try these also if you're using the same the same steps. If you're multiplying it by 2 and then adding 1 and then multiplying by -1/2 for those and being careful in your arithmetic, then you should be good to go. We're now going to give a symbolic description of g. I'm going to give myself a little room so I can simplify after I've written it out. So the output we obtain by taking x and multiplying it by 2 and then adding 1 and then multiplying all of that by -1/2. So let's simplify this down. This is 2x plus 1 is a nicer way of writing that, or maybe not nicer, but way that feels more familiar to me at least, and I believe to a lot of people. So then I'll distribute the negative 1/2 across, and I'll get 2x times negative 1/2 is negative 1x, or just negative x, and then plus 1 times negative 1/2 is negative 1/2. So this simplifies to g of x equaling negative x minus 1/2. And this is nice because we can pick out our slope of negative 1/1 and a y-intercept of 0, negative 1/2. We also see that same y-intercept in the table. So let's go ahead and plot this out. We'll go to the y-intercept first. Actually, let's get a scale on here. Let's make this 2 and then 4, so my grid lines are worth 1/2 each. That'll help us with that negative 1/2 value for the y-intercept. Get all of our scale written down here. This is expected. I do want to see scales on your axes. You don't need to label every single grid line. That gets very cluttered very fast. But every so often, so that we can quickly find the values of any points that we're looking at. All right, let's get the y-intercept plotted. So that's going to be here. And I'm going to wait to label it until I start looking at the slope. So the slope is down 1/1, and down 1/1, and down 1/1. And I could also go backwards, back 1 up 1, back 1 up 1, back 1 up 1, back 1 up 1. And I'm just going to double check, do we have the points from the table on here? If I go to negative 2, 3/2, that looks like it's right here. Kind of nice to just show those. And negative 1, 1/2 is there. Here's that 0, negative 1/2. And then 1, negative 3/2 is here. And then 5, negative 11/2. That looks like it's going to be down here. So a little out of the way. We can plot it if we want. And then we draw our line through these points. Keep in mind that for our table of values, one thing that becomes a little bit misleading if we're not careful or not thinking about it is to assume that we couldn't have plugged in like a fraction or a decimal. I think it's nice to plug in whole numbers, but the graph really shows us like, hey, this point's on there too. That's like, negative 1.75, positive 1.25, right? Oops. So decimal numbers are still part of this function for our inputs and outputs. Square roots are, weird numbers, they're all part of this function for the inputs and outputs. We can see that the function keeps moving to the left for forever and to the right for forever. So the domain is all real numbers, everything from negative infinity to positive infinity, and the range is also all real numbers, everything from negative infinity to positive infinity. And I am going to go ahead and label this function by the line y equals g of x. So you can see that that graph corresponds to the function g, and are explicit about it. I also spaced putting y and x on my axes, so let's get those labeled. And now I believe we're all set. All right, that's it for this problem. Thanks for watching, and we will see you in the next one.